Hi, I'm Max Warner from Group B16. I'm here to talk about Cantor's theorem. Cantor's theorem uses the diagonalization argument to show that the set of real numbers is uncountable. And so, before we get into the proof of Cantor's theorem, I'm going to familiarize ourselves with the diagonalization argument with a couple of simple examples. What we're going to do is, just in base 2, to oversimplify it, what diagonalization argument says is that if you take a part of each element from the diagonal to form a new item in the set, in this case 0, 1, 1, 0, and then change each of those, it'll be a new element that is not previously in the set. So in this case, we can change each of those to the opposite of what it was, and we have a new one, 0, 0, 1. And this would still be in the set from 0 to 1, but is a new one that is not represented. And the way we can this is proved is that if it were part of each one, by the time we got to the element that, so in this first case, if there was a 1 in this new element, we would have changed that first element, so there's no way that it could be represented by any of the previous elements. So now a more complicated example, we're going to base 10. We take one element from the diagonal of each one, in this case 4, 2, 3, and 9, and let's say we add 1, so to each one I, add 1, and then we'll just mod that with 10 in case it goes over. So then our new element would be 4, 2, 3, 9, and this would turn into 5, 3, 4, 0, which is also less than 1 and is a new element that wouldn't be represented by any other set. Alright, so this leads to Cantor's theorem, which we're going to prove by contradiction. We're going to assume that the real numbers between 0 and 1 are countable, and since they're countable, there exists a function such that from positive integers to the set from 0 to 1 of real numbers, that it is a bijection, which means it's onto and 1 to 1. So here's the representation of that set, where Dij is an element of integers from 0 to 9, and you can see that these R1 through R infinity would be, all of these represented here. Now, we can use diagonalization principle or argument to show that there's an element Ri that isn't represented before, which would be to take D11, D22, D33, and so on through the end of the set and create a new element by changing each one by the same principle. And this would be a new one that wouldn't be represented before. So it would just be D11 prime, D22 prime, etc. And what this shows is that there's an element from 0 to 1 that wasn't previously in the set from 0 to 1, which leads to the statement that since our preimage of the positive integers does not map onto all elements of 0 to 1, since there's a new element of 0 to 1 that wasn't previously accounted for, that shows that the cardinality of the positive integers does not equal the cardinality of the real numbers between 0 to 1, which means that the real numbers between 0 to 1 are not countable, which means all real numbers are not countable. That's Cantor's theorem by Group B16.